solar storms can wipe out satellites easily. A space weather expert said earlier this year, a geomagnetic storm destroyed 40 Starlink satellites. SpaceX launched 49 satellites as part of Elon Musk's Starlink Internet project on February 4, 2022, with the majority of them exploding in the atmosphere days later. A geomagnetic storm induced by the Sun was the cause of this more than $50 million disaster. Geomagnetic storms happen when space weather collides with the Earth. The Sun's oscillations send electrons, protons, and other particles into space, causing space weather. When space weather reaches Earth, it sets off a series of complex events that can be disastrous for everything in orbit. Engineers are attempting to better understand these threats and protect satellites from them. What causes space weather? The Sun constantly emits a steady stream of charged particles into space. This is termed the solar wind. The solar magnetic field is also carried by solar wind. Localized oscillations on the Sun can occasionally fling particularly intense bursts of particles in a specific direction. A geomagnetic storm occurs when Earth is in the path of heightened solar wind created by one of these occurrences and is impacted. Coronal mass ejections, which are eruptions of plasma from the Sun's surface, and solar wind that escapes through coronal holes, which are low-density regions in the Sun's outer atmosphere, are the two most prevalent origins of geomagnetic storms. The speed with which the ejected plasma or solar wind reaches Earth is critical. The greater the speed, the stronger the geomagnetic storm. Solar wind normally travels at 900,000 miles per hour. Strong solar events, on the other hand, can generate winds up to 5 times faster. A coronal mass ejection generated the biggest geomagnetic storm on record in September 1859. When the mass of particles collided with Earth, it created electrical surges in telegraph cables, shocking operators and, in extreme cases, setting telegraph equipment on fire. According to research, if a geomagnetic storm of this magnitude struck Earth now, it would cause nearly $2 trillion in damage. What is the magnetic shield? The Sun's emissions, particularly solar wind, would be extremely hazardous to any life form unlucky enough to be directly exposed to them. Fortunately, the Earth's magnetic field does a lot to keep humanity safe. The magnetosphere is the first thing solar wind impacts when it approaches Earth. This portion of the Earth's atmosphere is filled with plasma, which is made up of electrons and ions. The planet's strong magnetic field dominates. When solar wind collides with the magnetosphere, it imparts mass, energy, and momentum to this layer. The magnetosphere can absorb the majority of the energy emitted by solar wind on a daily basis. However, it can become overloaded during strong storms and transport extra energy to the upper layers of Earth's atmosphere towards the poles. This redirection of energy to the poles produces spectacular aurora displays, but it also creates changes in the upper atmosphere that might destroy space assets. There are dangers to whatever is in orbit. Geomagnetic storms can endanger orbiting satellites that help people on the ground in a variety of ways. When the atmosphere absorbs magnetic storm energy, it heats up and extends upward. This expansion raises the density of the thermosphere, the layer of the atmosphere that spans from about 50 miles to about 600 miles above the Earth's surface. Higher density results in increased drag, which can be problematic for satellites. This is precisely what caused the destruction of the SpaceX Starlink satellites in February. Falcon 9 rockets deliver Starlink satellites into a low-altitude orbit, typically between 60 and 120 miles above the Earth's surface. The satellites then utilize onboard engines to gradually overcome drag and reach their final altitude of around 350 miles. While still in extremely low Earth orbit, the most recent set of Starlink satellites encountered a geomagnetic storm. Because their engines couldn't cope with the increasing drag, the satellites began to plummet toward Earth and finally burned up in the atmosphere. Space weather poses a number of risks to space-based systems, including drag. Because of the huge increase of high-energy electrons in the magnetosphere during major geomagnetic storms, more electrons will breach a spacecraft's shielding and collect within its electronics. This accumulation of electrons can discharge in a minor lightning strike and destroy electronics. Even during minor geomagnetic storms, penetrating radiation or charged particles in the magnetosphere can change the output signal from electronic devices. This phenomena can produce problems in any component of a spacecraft's electronic system, and if the error happens in a vital component, the entire satellite can fail. Small faults are common and typically repairable, but total failures, while uncommon, do occur. Finally, geomagnetic storms can interfere with satellites' ability to connect with Earth via radio waves. Many communication systems, such as GPS, rely on radio waves. Because the atmosphere always affects radio waves to some extent, engineers account for this distortion when designing communication systems. Changes in the ionosphere, the charged equivalent of the thermosphere that spans nearly the same height range as the thermosphere, will alter how radio waves travel across it during geomagnetic storms. During geomagnetic storms, the calibrations in place for a peaceful atmosphere become incorrect. This, for example, makes it harder to lock onto GPS signals and can cause placement to be thrown off by a few meters. GPS location inaccuracies of a few meters are just not acceptable in many areas, including aviation, maritime, robotics, transportation, farming, military, and others. Autonomous driving systems will also necessitate precise location. How do we protect against space weather? Satellites are vital to the operation of much of the contemporary world, and protecting space assets against space weather is an important topic of study. Some of the risks can be reduced by insulating electronics from radiation or inventing radiation-resistant materials. In the face of a significant geomagnetic storm, however, there is only so much shielding that can be done. The capacity to precisely foresee storms would allow for some proactive safeguarding of satellites and other assets, such as shutting down critical electronics or reorienting satellites to be better protected. However, while geomagnetic storm modeling and forecasting have greatly improved in recent years, the estimates are frequently incorrect. The National Oceanic and Atmospheric Administration had warned that a geomagnetic storm was likely to occur the day before or on the day of the February Starlink launch following a coronal mass ejection. Regardless, the mission continued. The sun is like a child who frequently tantrums. It is necessary for life to continue, but its ever-changing nature makes things difficult. Thanks for watching, and be sure to watch for the next video.